Hey guys, coming to you from the beach to talk to you about systems of linear equations by elimination. Hopefully you can read everything okay. Hopefully you can ignore all the seashells and all the sand. Otherwise, here we go. Alright, so systems of equations by eliminations is all rooted in something called linear combinations. So linear combinations is basically when one equation is an exact multiple of the other. So if you take a look at this top equation that says 3x plus 7y equals negative 10, if I multiply all the pieces in that equation by 2, it gives me that second equation, 6x plus 14y equals negative 20. So, seems like a completely illegal thing to do. It is totally okay to take this guy right here, and then I'm going to put parentheses around that, and we're going to multiply the whole thing by 2. That's what we're going to end up using as a key to elimination. So, all we're doing is basically making all the numbers larger. Fun fact, if you graph this top equation up here, and you graph this bottom equation down here, they are exactly the same line. So it's almost like multiplying by 1 in a way, where you aren't really changing anything. If you need your teacher to prove that to you, you can ask her to do that. That's cool. Alright, so here we go. Now, elimination is kind of weird. However, it is my go-to method for solving systems of linear equations. So the equations that we have here are 4x minus 2y equals 6 and negative 4x plus 5y equals negative 3. So ultimately, for elimination, it does sound like exactly what we're trying to do. We're trying to eliminate a variable, and that's always the first step, is to choose which variable you're going to eliminate. It does not matter whether you're going to eliminate x or y. However, some choices are better than others. So what I want you to think about is, if we were to turn this problem into one giant old school addition problem with a big plus sign and the big bar at the bottom, if I were to add those columns straight down, which variable would end up canceling out? And in this case, hopefully you're thinking x. If I add 4x and negative 4x, those things are going to cancel each other out. So this one is ready to go. You're going to see the extra special weird kind of step that happens with linear combinations in the next example. So if I add these things straight down, 4x and negative 4x cancel each other out. So we no longer have an x for right now. Alright, then I have negative 2y plus 5y. That's going to give me 3y. Cool. And then I add the answers. We have 6 plus negative 3. That's going to leave me with positive 3. Alright, now I have this little baby one-step equation to solve. So I'm just going to divide both sides by 3. Just kind of like that. So these 3's cancel. So I know y equals 1. So in your work with systems of linear equations so far, hopefully you recognize that we are not quite finished. We still have to make that final coordinate where our lines cross. So our answer is still going to represent that important point where those lines are crossing. We're just not going to get a visual of where that is. We're just going to see the coordinate at the end. So similar to the substitution method, which you might have already looked at, we're going to take this y value that we just got, and we can plug it back into one of those two original equations. Pick your favorite, it doesn't matter which one. I'm going to go for the top one. Less negatives, so less likely to make a mistake. So hopefully I'm writing within the frame here. We got 4x minus 2 times 1. I think it was a minus sign, thank goodness, yes. Alright, equals 6. Alright, from there I'll multiply here in the middle. So I'll have 4x minus 2 equals 6. Do you like my seashell pencil? It's great. Alright, and then we have a nice little two-step equation to solve. We'll add 2 on both sides. So I have 4x equals 8. And when I divide, x is going to equal 2. Okay, still one step left. And that's to take this x value that we just found and that y value that we found back up here, and we're going to turn that into a coordinate. Okay, so our x value is 2, even though we found it second, it still comes first. And we got 1 back here. Alright, and that makes our final answer for that guy. So that ordered pair, 2, 1, represents where these two lines from way back up here cross each other, and that's the solution to your equation. Alright, weird part about elimination is that sometimes your equations aren't already magically set up to do what they need to do. So if you take a look at these, if I were to try to do that giant addition problem again, neither of my variables are going to end up canceling out. 5 plus -3 doesn't equal 0, -2 and -6 don't make 0, so I'm kind of in a bad shape here. However, what I can do is I'm allowed to use linear combinations to make that happen. You'll notice that it doesn't really matter whether I have the answers on the screen. Right now we're focused on the variables. So if I were going to make a smart decision about which variable to eliminate, I'm going to select y. Here's why I choose y. It's easy for me to turn a 2 into a 6 using multiplication. So I can create a linear combination of that very top equation so that that 2 and 6 will actually cancel. So if you think about what we can multiply to turn a 2 into a 6, that's going to be 3. However, I have to be a little bit careful. If I do that, okay, I'm going to go ahead and do that because I need the 3 for sure. But there's one other thing that I'm going to need. So I'm going to put big parentheses times 3 here. All right, cool. Now, if I multiply this 2 by that 3 that we decided on, unfortunately, this negative and this negative are not going to cancel out. I need a negative and a positive to make that happen. So I would want this number to be a positive 6 so that it'll cancel with this negative 6 when I make that addition, and my y's will cancel out. You could try to do this with the x's, but it's hard to turn a 3 into a 5 or a 5 into a 3, so that's why I'm focusing on the y's here, okay? So I'm going to have to multiply by a -3 instead. Okay, let's talk through why we chose -3 again one more time. All right, we selected y to cancel out because it's pretty easy to multiply 2 by something and turn it into a 6. All right, the number that we need to turn -2 into a positive 6, because positive 6 and -6 would cancel, we need to multiply that -2 by a -3. Okay, now we can't pick and choose to just multiply that -2 by -3. We're going to have to multiply that whole equation by -3. So that's what this next step is actually going to look like. I'm not really ready to add yet. So if I multiply the entire top equation by -3, I'm going to have -15x plus 6y. Good thing sand can erase. That was the whole point, to get a 6, and here I am trying not to do it. And then -3 times 26. Doing this on the fly without a calculator. Hopefully I don't make any mistakes. I know I have an 8 in the back. Looks like -78. Hopefully that's right. Alright, we got -15x plus 6y equals -78. The bottom equation I'm going to leave exactly the same, so I'm just bringing that one down. -3x minus 6y equals 6. Okay, don't panic. When I was learning this, I always freaked out about, oh gosh, I multiplied by -3 and now my x has changed to something way different, and the answer back here has also changed to something way different. Is that a problem? The answer is no. No, that's not a problem. That's good. That means you did your linear combination correctly. All right, so now that these y values match here, I'm ready to cross those out and do my giant addition. Don't just get slash happy. We want to make sure that they do actually cancel out. I have a +6 and a -6, which is going to cancel. Sweet. All right, so now I have -15x and -3. That's going to make -18x equals, all right, -78 plus 6 is going to make -72. I divide -18x and -72, x equals +4. Alright, similar to the last one, we're not quite finished yet. We still need to finish off that coordinate. You want to go back to your original equations, okay, not the multiplied version, just in case you made a mistake. This will help kind of show you where that happened. Let's see here. I think I'm going to take the top equation. So I'm going to have 5 times 4. Be careful about where you plug it in. This one's an x value, unlike on the last one. All right, we got 5 times 4 minus 2y equals 26. All right, 5 times 4 will make 20. negative 2y. Alright, equals 6. And whenever I divide, I'm going to have y equals negative 3. Kind of like that. Alright, one last step, and that's to make that final coordinate, taking that x value from way up here and the y value from way down here and putting those together. So my coordinate's going to look like 4, negative 3. Yeehaw! Woohoo! Alright, just a couple more. On this one, this is where the elimination method is really helpful. If you were trying to do substitute or use the graphing method to solve this, it would not be pretty. You're going to end up with lots of weird fractions. Fractions are no fun. So what we're going to do instead is we're going to try to eliminate. Now, if I look at my numbers, none of them really play nicely with each other. So I'm really just going to pick what's going to make a smaller number. So in this case, I'm going to try to eliminate x. And that's because I can turn a 2 and a 5 into a common number, which is 10, pretty easily. If I was going to work with 7 and 3, I could turn those into 21. However, that's just bigger. So I'm just going to try to keep my numbers smaller here, since I haven't checked any of my work or done these problems before right now. All right, here we go. So if I'm trying to turn 2 and negative 5 into something that will cancel, it means I'm going to need a positive 10 and a negative 10. It looks like my signs are already opposite. We got a positive up here and a negative down here. So that means we're really ready to go. So that means I'm going to multiply the top equation by 5, the bottom equation by 2. Alright, so I'm going to put my big parentheses, basically distributing those numbers to everything. Alright, and then a 2 down here. Sorry for the giant seashells in the middle of this one. Alright, so if I go ahead and multiply and get those equations changed up, I'm going to have 10x plus 35y here's a doozy. Alright, we got 5 times 37, so that's going to be 185, I believe. Hopefully that's correct. We'll find out soon enough if it works out. Alright, down here on the bottom we'll have negative 10x. And that's awesome. That's what we were hoping to get. Sweet. So let's keep going. So then we have 2 times negative 3y, which will be negative 6y. Ooh, right in the middle of the footprint there. There's a negative there. Be careful. Alright, then 2 times negative 20, which will be negative 40. Awesome. Okay, that means we're ready to add straight now. Almost crossed out my 6y there. Jeez. Okay, so my x's should cancel. That's what we're aiming for. We have 35y minus 6y. That's going to make, looks like positive 29y. Alright, 185 minus 40 is going to end up making, let's see here, 145. When I divide by 29, y should equal, let's see here, y should equal 5. Sweet, I did do it right. Yeah, pretty good for vacation brain. Alright, so from there, I'm going to take that y, plug it back into my original equation. So I think I'm going to go for the tippy top one up there, the 2y plus 7y equals 37. Hopefully you can read that okay. So we have 2x plus 7 times that 5 that we just found. And that's supposed to equal 37. Yeah. Alright. 7 times 5 is 35. Oops, I'm trying to jump to the answer already. Yikes. Alright, there's my 37. Alright, if I subtract 35, we got 2x equals 2. So x will equal 1. Alright, don't forget to write your final answer as a coordinate that represents where those lines are crossing. You can always graph to confirm. although it would be very fun on this one. All right, so we got 1, 5. Great. Okay, last scenario. All right, this one I set up to work the way that I want it to work. So we don't have any multiplication to do. I tend to like to eliminate y personally. I like to get x first. So if I focus on those y values, I already have a positive 4y and a negative 4y. So I am ready to add. Hooray. So I know that positive 4y and negative 4y are going to cancel out. However, if I look at my x's, I have negative 2x and positive 2x. So when I add those, I've also accidentally slashed those ones too. Oops. So all I have on this side now is big fat 0. Okay, I ran out of all my variables, which is generally not great. However, it's going to make this problem really short. So then on the other side, I have 10 minus 5, which is going to be a positive 5. If this happens and both of your variables cancel out, you're at a decision point. You want to ask yourself, is the statement that I have left true or is it false? If it's true, you're going to end up with 0 equals 0 here. Otherwise, it might be 0 equals something else like we have here, 0 equals 5. So 0 does not equal 5. So what that tells me is that these two lines are actually parallel and they do not cross, which means my final answer is no solution. Alright, had it been something that's true, like 0 equals 0, you would get something like infinitely many solutions or all real numbers, however you want to describe your answer. Alright guys, I hope that you've enjoyed this lesson about elimination today. I'll end with a shot of the ocean. Thank you for joining me for my